right? So here we have 2 power n must be greater than the number of subnets. In our case, we want to have 3 subnets, right? So what is the value of n? So this number must be greater than 3. So if we take 4 is greater than 3. So what is the value of n that we will put it here and have 4? It is 2. 2 power 2 is greater than 3. So how much bits we need? We need 2 bits to have that number of subnets that we need. So instead of having 16 bits for network and 16 bits for host, we will have instead 2 plus 16, it is 18, and here when the number of the bits equal 32, we must to put only 14 bits for the host. Then all this portion will be yellow, as here, and then paste it here. So as you can see that the portion of the network changed, and here we have only 2 bits, right? And how can we now take, or what is the IP address of this subnet and of this subnet and of this subnet? As long as that we said that we have 2 bits for our subnet, right? Then I will I have to I have to binary. I have to write this in binary because this is in decimal. So I have to put it here, and I don't want I have not to touch this one, but instead I have to touch only this one, right? Why? Because there is something that forced me to do not touch this one, but to touch only this one. This thing is called net mask. Is the mask. It is by default the highest value is 255.0 and the lowest value is 00. So when you have 255, it means this value we have not touched it, and the same thing here. But what remains is only these 2 values. These values is right in decimal. We have to convert them to binaries. In binaries, they are equal to 8 zeros, 1 2 3 4 5 6 7, 1 2 3 4 5 6 7 and 8. Thus 1 2 3 4 5 6 7 8, right? And then we have to take how much bits? 2 bits here, and these 2 bits I have to convert them to 1 1, right? So what is the new net mask will be? The mask of this of network mask, this network mask will become, if if I will give you, because in binary to calculate this we do 2 power 0, 2 power 1, 2 power 2, 2 power 3. So here we will have, this will be, it may come down here, and then it will be 128. and the other one is 60 64, then 0 0 0 0 0, because to convert a binary to decimal we do the value that is here multiply to power and then calculate from here 0 1 2 3 4 5 6 7. So yes, 7 power 8 power 7, sorry. This is how we calculate or how to convert from decimal to binary. I hope that is clear for you now. Then we combine these two values, right? And let us combine them and see how much. You can do some calculation and then answer that, and it is equal to 192. So the new network mask is 255 255.0.0, right? And then the first IP address here, it will be, because when we have two bits of network, that not means that both of bits will have 1 and 1. Maybe there are probabilities here that I will show you here to have 1 1, and then I will repeat only this bit. Maybe we can have 1 1 or 1 0 or 0 1 or 0 0. So there are four possibilities here. So the first possibility is to have 0 0 0, and then the first IP address here, it will be 24.0.0, and then slash, and here we have to give the number of the bits of the network. How many bits for the network portion? It is 18. And then the other possibility here is to have 1 here and 0 here, and then the subnet will be 176.24.128 here, because here we have 0 and then 1, then 0 multiplied by 2 power 6, it will be 0. Then we have only the rest will be only 128.0. Then the number of bits is 18. And the other possibility here is to have 1 here and 0 here, and then if we do 1 multiply 2 power 6, it will be 64, and then we will have a subnet that is 176 and dot 22, then 64.0, then 18 for the number of bits for the network portion. I hope that is clear for you now. Let me come back and explain you what I am intended to explain you during this lab, right? Let me come here and then duplicate that using Control Shift D, Control Shift D, and then it is duplicated. And then scroll down here and look for an instance. Does not matter what is it, but compute an instance right here. Right? So once you launch an instance, a network interface comes with it. So let me scroll down here and look for, yes, this one, Elastic Network Interface here comes with it. In reality, when you launch an instance, it resides in availability zone within a public subnet. Then in that subnet, an interface